Good afternoon, everybody. Welcome to the very last session at PDC 2008. Everybody have a good time? See enough content? Everybody have enough beer last night? All right. I'm Mark Brown. Welcome to Live Platform, BB10. This is a deep dive on Virtual Earth. And I'm Mark Brown, Senior Product Manager for Virtual Earth here at Microsoft. So I kind of want to just kind of get a sense of who we have in the audience today. So show of hands if you've used Virtual Earth before. Okay. All right. And then anyone who's new to Virtual Earth? Okay. So a lot of Virtual Earth veterans in here. That's pretty scary. Pretty scary. So just a little about me. I've been writing software since 1992. And back in those days, we had lovely VB3 and tools like Power Builder, FoxPro. This was pre-SQL Server, so it was Sybase back in those days. And my favorite, Btrieve. Good time ISAM technology. Did a lot of EDI, EAI types of applications, a lot of back-end glue, just building enterprise line of business type systems. And then I've been with Microsoft since 2000 and started doing some data warehousing and lots of very large scalable database type projects. Been kind of a VB SQL guy for most of my career. And then decided I wanted to try something a little different, so I went from writing some of the largest systems on the planet to some of the smallest little applications on mobile devices, which was more fun because you can take them and show them around to your friends. And then moved into developer and architect marketing about 3 years ago, and now I'm with the Virtual Earth team. I've been on this team since February. So agenda here, lots of content. I'm going to give you kind of a high-level 50,000-foot view of Virtual Earth platform, and we'll talk about each of the services within it. I'll give you a very quick little example of kind of the basic anatomy of any VE application using the Virtual Earth map control. And then we're going to do a deep dive into two different things. So we just had a new release of Virtual Earth map control version 6.2 at the end of September. So I'm going to do a quick deep dive on that, and we'll show you some of the new features and crack open some code here. And then I'm going to introduce and we'll talk about our new Virtual Earth Web Services 1.0, which just released as well back at the end of September. Roll that all together. We put together a really nice, cool VE and SQL spatial demo. So I think Virtual Earth is a great, beautiful environment to be able to visualize data, but when you combine it together with the new spatial capabilities in SQL Server, I think it's just incredibly compelling. And so I want to show you a little demo we put together just to give you a kind of an idea of the power you've got there on the platform. And then quickly, a little more information slide where you can go to get all kinds of great samples. I will have all of the samples you see today available online at the end of this session, including a bunch of bonus content that we built, but I just did not have enough time to go show you here today. And then we'll wrap it up with a panel Q&A. So I've got three of the smartest guys on the Virtual Earth team here with me today, and I'll bring them up on stage. And then if you could, at the end of the session, just hold your questions and then use the microphone so that we can capture your question during the recording here. So let's talk a little bit. What is Virtual Earth? I think most of us recognize it's obviously our online mapping platform. But more than just the map and the image tiles that are in there, there's a lot of other services that are surfaced within the Virtual Earth platform, including our elevation and 3D models, search capabilities against our points of interest database with white pages and yellow page listings, geocoding engine in there, the ability to be able to get at user-generated content such as our live maps collections, and then other really interesting data as well that you can leverage in your Virtual Earth application, such as traffic data, and then, of course, building routing and directions where you can integrate the two together. All of this exposed through both the Virtual Earth map control, our AJAX control that you can use on your web development, and now our new Virtual Earth Web Services. And a great example of where all of these things come together is, of course, our Live Maps application. That's our consumer online mapping solution. But certainly, you could take advantage of all of the different platform services that we've got in here. And as we go through the session today, I'll try and we'll cover off on each one of these. So the obligatory company slides, I call this the slide of 1,000 logos. It just shows that Virtual Earth is used and trusted by leading companies worldwide. building applications to help them connect better with their customers, whether they're building a store locator or help find an ATM. Many real estate companies get a lot of value out of using Virtual Earth to service the properties they have for sale or rent on their sites. And then companies now are starting to build a lot of internal line of business applications and use Virtual Earth to view their data spatially. This could be insurance companies that are looking at fire claims or insurance over a map, or companies that are doing asset management or fleet tracking are finding a lot of value in using Virtual Earth today. So we'll do a little bit of just a high level of the Virtual Earth AJAX control. And for most of you here, I think a lot of this is very obvious or well known to you. But I just want to kind of cover off on each of the things within the map control itself. So to begin with, of course, the hostable map control itself that provides access to all of our 2D data, such as the road and aerial imagery that you see within Virtual Earth, and then, of course, our 3D data as well. And then secondly, navigation tools. So up on the left-hand side, navigation tools to be able to switch from different map styles and also to be able to zoom in and pan on the map. And then, of course, events and callbacks. So when you're writing your applications, allowing you the hooks to be able to capture the input from your users and then be able to provide a richer experience to them. In addition, support for shapes. This could be as simple as like a push pin that you put onto a map for a point of interest that your user selects. But also native support for things like polylines that you can draw or your users can draw within the Virtual Earth map or on top of the map control. And then things like polygons. And I've got a great example or sample at the end of the show where I'll show you how using a polygon can yield some really great information for you. And of course, we've got Find. So access to the geocoding engine within the Virtual Earth platform, or being able to search the white and the yellow page listings. And then, of course, our user-generated content. And then routing, of course, and this includes obviously simple point-to-point routes or multi-point routes where you've got lots of different waypoints. We can expose that in terms of driving directions or even walking directions. And then, of course, you can integrate traffic data within there as well and help route your customers around areas that have got heavy traffic at that time. And then finally, integration with external data. And we have native support for both the GeoRSS and KML formats for vector data. And then, of course, can support if you want to create your own custom tile layers, we can support that as well if you want to take your images and run them through Map Cruncher provided by MSR. So here, this is the canonical Hello World Virtual Earth application, but all VE applications have really three basic elements. First is the reference to the script control at the top of the page here, so Map Control version 6.2. Secondly, we need a place to host the control on the page, so all Virtual Earth applications have a div tag where you then reference the control in there. And most often they have a function in there called getMap or getSomething that you're going to then use to then instantiate the control, and then called loadMap or anything else that you want to do to manipulate the map and set it up for your customers. So let's do a little deep dive on our new Virtual Earth 6.2. So one of the first things I want to talk to you about is our ability to expose our imagery metadata. So this is a feature that a lot of customers have been asking us for a long time, in that they would look at a map and see aerial imagery and say, how old is that image that you've got in there? And for the longest time, we just couldn't tell them. So now, new to the version 6.2, you can go in here and actually request the image metadata for the imagery on your map. In addition, we can also provide you that provider data for the image data on there as well. And I'll show you a little example of this a little later in the session. The second feature is now available, routing landmark hints. So available just in the US and Canada. This provides a richer experience for your customers when you're creating routes for them, because we can expose now landmarks such as gas stations or banks or restaurants. And typically you're going to have signs that are much larger than the street signs that they're using to navigate with. So this is a way to provide kind of a richer experience for your customers. So with that, let me kind of give you an idea of what this looks like. So here I had just a really very simple ASP page. Actually, this is a little HTML page. And we just have a from address here, and then a to address here, and then a little map control. So what I'll do is we'll click the button. So we'll show the route here right on the map using these lines. And then, of course, your turn-by-turn directions, and then off to the right here, if we've got landmark hints, we then expose them out here. And then, of course, at the end of your destination, we'll provide you the previous intersection and the next intersection so that they can use that to know when they're coming to their destination or when they've gone past it. So how do you do this? I'm going to show you. So here we have our little HTML file. And then again, right here at the top, have the reference to our map control. And then a little function down here, load map, which is called right when the page, on the body on load for the page. And then in here, a little function called get directions. So what we'll do is we'll take the from address and the to address off the HTML page and just store those here locally. Next, we're going to create a new instance of a VE route options object and just set a few properties here. So we'll set the distance unit to a mile, and then we'll set our VE route mode to driving. The other thing I want to point out here too is we're going to specify a callback in this thing because sometimes when you're doing routing, the routing itself can take a little longer than actually generating the map on there. So to give it a little better user experience, what we'll do is we'll create a little callback here and then point that at a function that's going to get called after the get directions here. So here we go with map.getDirections, and then we'll pass in an array from our from and to value, and then pass in the options that we created up here above. And then that'll generate the map. And then in the callback here, so we have our show route, what we're going to do is just dynamically create a little HTML table and then iterate through the itinerary items within here. So within the table text here, we'll add the distance. Here's your turn by turn. And then here below the secret sauce, so we'll check to see if we've got any hints. And as I said before, there's three types. So we've got the previous intersection here, next intersection, and then the route hint type landmark. And that's it. Pretty easy stuff. And the next feature, new to Virtual Earth 6.2, is we now have got localized tiles for parts of Western Europe. So included in this is US English, German, French, Spanish, and Italian. And then, of course, we add that to our already having support for Japanese maps for Japan here. Now, implementing this is really dead simple. It's essentially, if you can see at the bottom here, you just simply add a market parameter to the map control reference right there. So I'm not going to actually demo this, but I just kind of wanted to show you. So here I've just got 5 maps all loaded up in an iframe, and each one of them has a market parameter set differently. So you can see here is in Spanish. Oops. I've got them all kind of, there we go. So in Spanish, Italian, German, and French here. But you can see it's very easy to implement. Oh, yeah, there's my demo. The next feature I want to talk about is one that I'm really, really excited about, and one that, again, a lot of customers have been asking us for. The notion of push-pin clustering becomes relevant when you're building applications that have got a lot of push pins in very close proximity to each other. Now, what you end up with as a result is that at many zoom levels, it's very difficult for your users to interact with the push pins. So what we did is we've now enabled push-pin clustering natively within Virtual Earth 6.2. So, and I really want to show you this. This is a cool demo. Okay, so what I've got here is just another simple HTML page. And I'm loading up here, this is all the earthquakes that occurred throughout the world in the month of September. So we have 772 earthquakes here loaded up, or 772 pins loaded up here on this map. And so the notion of push-pin clustering is to take lots of individual push pins. So we've got an individual push pin here, and you can see all the detail for that earthquake. And then we'll use a separate icon here to represent lots of different push pins that are all within close proximity. So here you can see 319 for Southern California. That's not surprising. And we'll kind of just zoom in here. There, and you can see as they start breaking out now. So these are going to be clustered in different locales to each other. And then you can start to see some of the individual ones break out here. So this is the notion of the pushpin clustering, where it takes and clusters and unclusters based upon the zoom level you're at, and which makes it, I think, a far richer experience for customers to be able to interact with the data on your maps. So let me show you how you do it. Oops. So here you have a simple HTML page, and then I've got one icon, earthquakes.png. This is the clustered icon that we'll use to represent, so it had the multiple circles on it. And then a single icon, or earthquake PNG file, that'll represent the single pushpin. And then all I did was just took and opened up this JSON file where I've got all the earthquake data sitting in here. Okay. So again, we'll create our reference to the map control here, version 6.2. And then I've got my load map function, and I'll new up a new map control, and then call load map on it, set some styles here. And next what we'll do is I've got a function here called get pins. And so let's go. And this is what we'll do is we'll load up all the pins inside here. So first what we'll do, create a new array of pins. And then for each of the push pins, you have to create a new VE custom icon specification. So we'll set that here equal to our single pin, so earthquake.png. And then next, we'll loop through our earthquake data file here, and then create a new VE shape of type push pin. And then we'll add our latitude and longitude so that we can locate it on a map. And then just simply go and just add in the rest of the data that'll show up in the info box there. And then we'll just add that to our pins array right there. Okay. So we've got all our pins loaded. Next, we'll then call add shape on the map object here, and then add in our array of pins. And then there we'd pretty much be done, right? But not now. Now we can go ahead and do our clustering within version 6.2. So we'll create another icon specification here and specify this as the earthquakes.png. Next, we'll start working on our clustering options here. So we'll create a new VE clustering options class, set its icon to the new icon we just specified above. Next, we'll go ahead and we'll get the base layer on the map here. So get shape layer by index 0. So this will get the default layer, the default shape layer on the map. And then we'll set on that shape layer our clustering configuration, and we'll specify VE clustering type grid. So we specified VE clustering type grid. It's actually the only one that's supported in this version right now. But if you want, and I know maybe some of you know this, but there's actually a lot of good technical articles out there on if you want to create your own clustering algorithm. So maybe a grid doesn't quite work for you, or you want to have more control over that. So go out to MSDN or just on the internets there and search for virtual Earth clustering, and you can get some great articles on that. Well, that's basically it. Pretty simple. So next, let's do a little breakdown on the Virtual Earth Web Services. So 4 brand new web services available now, SOAP-based, and let's just kind of do a high level of them, and then I'll start digging into some cool features. So the first is our imagery service, and it provides access to, of course, all the imagery in there, but also the regular vector maps and tiles within there as well. And you can also get imagery metadata that I talked about a little earlier in the session, where you could get the vintage data on the imagery within there, and then also the providers. Our second service is the search service, so providing programmatic access to our white and yellow pages points of interest database, as well as user-generated collections. And you've also got some flexibility in there where you can do a one-box search, so any input that you get from your customers, you can pass it straight in and we'll parse it. Or you can do more of a structured search as well with keyword and location. The third service is our geocode service, so of course support for regular geocoding as well as reverse geocoding. And then next, our route service, so the ability to create simple point-to-point routes or multi-point routes, and then also now support for creating major routes. And these are most commonly referred to or seen on our live maps as one-click direction. So if you've gone and done a search and then clicked on that, and then seen that static map image on there. That's the major routes featured there, and I'll show you that in a little bit. The next service I want to talk about is actually not a new service, but is required to use all of these other services. So to use the Virtual Earth Web Services, you have to get authenticated through our common service here. And this is actually part of our legacy MapPoint Web Services platform. And I'll show you an example of how to use this, but to get any of the calls within here, you have to go through and authenticate first and then grab a token on behalf of your user, and then you can use that to make calls into the web services. So the first feature I want to talk about is static maps. So new Virtual Earth Web Services offers static maps that you can go and create for road and aerial maps. And they're very simple to get. You go and just create a new map URI request object, set its credentials obviously, and then set the center point for the image that you want the Virtual Earth platform to create for you. Pass in the latitude and longitude, the zoom level, and then the size of the resulting static image you want it to bring back to you. And I'll show you an example of this in a minute. Secondly, within the imagery service is our imagery metadata and tiles. So unlike static image maps, tiles are standardized 256 by 256 inch JPEG files. And accessing them is roughly the same. You create a new imagery metadata request object, and then you pass in your latitude and longitude and zoom level, as well as the map style as well. And then we'll return that back to you. And then, of course, also you can get your imagery metadata on that. So instead of talking about it, let's just show you. So right here, I've got a page, and this place should look familiar to all of you by now, the Los Angeles Convention Center. So the three main things we need: latitude, longitude, and zoom level here. So then I can change the zoom level. And then it's going to go request this image right here. And so the latitude and longitude I'm passing in is essentially the center point right here in this image. And then at the bottom here you can see it doesn't actually bring you back a blob, but actually it brings you back a URI that you would then use. So we've got it here in just an image control, an ASP.NET image control. Then you just set the URL, image URL for that. You can display it here. So let me show you how you do it. So here's our simple little ASP.NET page. There we are. So just a text box here for latitude, longitude, a little drop down, and then our little image control right here. So first, I'll talk a little bit about the first thing we want to do is obviously create a new reference to our map URI request object. So this is the request object that's going to go and create for you the static map. Before I get too far, though, I want to talk a little bit about credentials, because you're going to see this all throughout the presentation, the demos today. Every time you create a new request object within the Virtual Earth Web Services, you need to set its token. So the way we do this is to create a new credentials class off the map URI request object. And then what we'll do is we'll set the token property for that. Now I've got a little function we've created here just called utils.token. And in this instance, it's going to take in the user IP address. And I'll show you why in a minute. So let's go and run to this right here. So here, what we're going to do is we're going to create a new instance of our common service. So this is the other of the three of the services that are available within the platform. So if you look within here, I've got your 4 services. And then here, this is the older style ASMX web service. And this is the common service that you'll have to use to do the authentication within here. So to do this, you've got to go get credentials. So thankfully, you can go and just get a developer eval account. And I've got a URL in here for you to go and sign up. If you've got a production account already, that's fine. All you need to do is then pass in the credentials that you've got. And in this case, I've stored them in our web config file. And after we've passed those in, what we'll do is we'll create a new token specification object And in here, you have to set the duration for it, and that could be as little as 15 minutes or as long as 8 hours. Now, something of a, how do I put this? It's a little tricky in that you're going to need to maintain this thing or somehow persist the fact that this thing has got some duration on it. So you wouldn't architect the way I've got it here, but if you're managing user sessions or whatever, you would want to tie this token with your user session or somehow persist that in some way that you're going to be able to maintain state, because it won't tell you when it's expired. You'll just call it, or you'll call the web service, and the token will be expired, and it'll go into an error. So maybe you want to check it or check the time, and then you can do that, and then when it's expired, you can then go and get a new token. But generally, that's easier than having to wrap everything in a try-catch block to figure out whether or not your token is expired. So, and as I said before, it also accepts the client IP address. We realized that for people who are building desktop applications, it's not not appropriate to ask for a client IP address. So this thing will accept any valid IP4 address, so you could pass in all zeros if you wanted to, if you're writing a desktop application, because you're obviously not going to have the client's IP. Well, you could, but not for like a web application. Anyway, once we get all that information, we'll call getClientToken, pass in the token specification we created here, and then return that back to the token property on our map URI request. Okay, moving on. After we've done that, we've got ourselves authenticated. We're going to set the center point for the imagery request here using the latitude and longitude we pulled in off the client. Next, we're going to set some options. So we're going to set the size of the image we want. And in this case, we're going to host it in our image control. So we're going to take the height and the width value out of there and set the image size of the in the map request. Next, we'll set the zoom level we want, and then finally, we'll set the map style. And within here, you can set aerial with labels, and road. We do not have bird's eye support yet within this function. Okay, so we've set all our options. We're all authenticated. Next thing, we're going to create a new image service client, and this is the class that will make the request for us right here. So what we're going to do is call getMapURI, pass in our request object, and then using the response, we'll go ahead and set here the image URL to the URI property for the response object there, and then just simply write out at the bottom of the page there. So maybe a little confusing. I was kind of confused when I first started looking at this. But really, for all the services, and you'll see this throughout the rest of the session, the pattern is always the same. You're always going to have a request object. You're always going to have some options you're going to want to set on it. You'll always have a service client that makes the call, and then you'll always have a response that it brings back to you that then you're going to then take and pull all of the data out of the response object. Okay, so static map images. What am I doing on time? Okay. Next thing I want to show you is our tile and metadata. So also within the imagery service, but a different request object and a different function call off the service client. So what we'll do is we'll load up our image metadata and then a tile that we requested. So we've passed in a latitude and a longitude again, and then specified a zoom level here. Now what you get back is an image URI, but you'll notice it's somewhat different than what we got. So if you can see here, what you see is this rather oddly named JPEG file. This essentially represents our virtual Earth tiling system. It's kind of like an address system or a quad key, if you will. And what this allows you to do is being able to request tiles. There's some logic in terms of how the numbering scheme or naming scheme of these tiles is put together. So you can use it to get other tiles around this here, because obviously if they all come back at 256 by 256, that's not going to be big enough for many of you that are building applications around it. So if you look at the difference here, the map URI, in here, in JPEG. Can you guys see that? Yeah? Okay. So let me show you how to do this. Okay. So what we'll do is first we'll create an imagery metadata option. So this is the name for what we're getting in here is imagery metadata. class. So what we'll do is we'll start with an imagery metadata options object, and then we'll set the location. Now, the location here is not necessarily going to be in the middle of the tile. These tiles are all the same, but what it will do is it'll look up, and for the tile that has that latitude and longitude at that zoom level, that's the tile that will return to you. So it's different from what you got here in the static map. When you pass in the latitude and longitude here, it's always the center of the map. It's not always the case here. So we'll set the latitude and longitude for our location, and then set the zoom level. Create a new imagery metadata request object. We'll set the options for what we just set above there, and then set the map style area with labels here. Next, we'll set our credentials. Create an imagery service client. The same imagery service client we used to get the static image, but we're calling a different function this time. Get imagery metadata, and then of course we're passing in a different request object. The backside of this thing with the response object is very much the same. So you're going to set or pull the image URL out of the result object, and then here we're just emitting out some of the metadata for that tile. So we have the vintage from and to, and then just the zoom range. Okay. So the next service I want to talk about is our geocoder service. And then for those of you, since most of you in this room know, a geocoder takes some kind of location information, address, state, zip, city, whatever, and then provides you a latitude and longitude for that. And then of course our reverse geocoder does just the opposite, taking a latitude and longitude, probably something that maybe your user clicked on the map, and then provides you an address or location information for that. Our geocoding service actually has two geocoding engines within it. One that provides our rooftop geocodes, and then a second one for generating interpolated geocodes. So let me show you a little demo on that. So here I have a very simple web page, and I have an address here. This actually happens to be the hotel that I'm staying at, the Bonaventure down the street there. And what we'll do is we'll geocode it. And if you look here, we actually got two calculation methods. So it produced a hit against both of the geocoders. We got a rooftop geocode, and then we got an interpolated geocode as well. And I don't have a graphic of this, but this rooftop geocode actually puts a push pin right square on top of the property, right there. The interpolated one actually sticks one out in the street. Still, it's pretty close. What we'll do is then we'll go ahead and reverse geocode this here. So again, what you'll see on the flip side of this thing is the actual address of this property is 404 South Figueroa, right? And look at the confidence you see here. So in some cases, you're going to get back two responses out of a reverse geocode. And if you do that, you're going to want to select the one that's high, and in this case, that's the correct one. 451 Flower Street's on the backside over by the parking garage. It's not bad, but it's not the exact address for that property right there. So let me show you how to use our geocoder. Okay. First thing we'll do here is we'll create a new geocode request object. And then, of course, we're going to set the token for it there. And then simply set the query property and just pull in the address, the full address, from the HTML page. Next thing we'll do, create a new geocode service client, and then just simply call the geocode function off the client there. And then, of course, using our response object, we'll loop through all the results in there, and then just emit out all the data that came back. The reverse geocode, not surprisingly, much the same, except we'll create a reverse geocode request object this time, set its token, and since it takes the latitude and the longitude, we're going to set a location property on that, passing in the latitude and the longitude we got from the web page. We'll call the same geocode service client, although in this case, we're going to call reverse geocode, passing in the reverse geocode request. And then again, we'll emit back out all the results. So the next service I want to talk about is our search service. And like I said, it provides programmatic access to our white and yellow page listings and then also our live maps collections in there. And you can do either single box query, so we'll just take in all the input you pass in, or your customers pass into us, and we'll parse it. Or you can do more of a structured query, which is very beneficial, let's just say in places where the addressing systems can get a little awkward. So you really want to separate that out. And what you see here is, so you have a structured search query with keyword and then location. And that'll help the parsing engine find the right answer for you for locations where it gets a little sketchy in terms of the addressing in there. Next service I want to talk about is our routing service. And like I said, this provides the ability to be able to do simple routes or complex multi-point routes. The means to be able to doing this is to simply take and create new waypoints. Then you just add them to the route request. And then you call calculate route. And I'll show you an example of that here in just a minute. But before I want to talk, we've got major routes as well. And like I said, these are more commonly referred to as one-click directions or party maps. And certainly provide other options as well to provide shortest distance or shortest time, or you can even integrate traffic flow within there to create a better route for your customers. So let's kind of dig into routing and search. Okay, so right here I've just got a simple web page again, and we've got a from address and a to address. So this is one Microsoft way, pretty familiar to most of you. And this address is Safeco Field, actually, in Seattle. So what I'll do is I'll just call get directions. And then here we go, our turn-by-turn directions returned right here at the bottom. So let me show you how we do it. Okay. First thing, we'll create a new route request object within here and set its token. And then next, we're going to create a generic list of waypoints in here, and then we'll add the location. So since the locations we started with was an address and not a geocode, and we need, a latitude and longitude for each of them, we created a little function here called get waypoint from address. And what this is going to do is this is going to leverage the geocode engine we just talked about. So within here, I'll create a new geocode request object, pass in the address into the query property, and then go and call geocode on it. So we'll go and do that for both of them on the add function here. And then for the waypoints property, we'll just simply take our generic array and then call waypoint list to array, and then set the property of waypoints. Next, after that, we'll go ahead and take and create a new route service client. And then we'll just simply call calculate route. And then taking the results from that there, we'll go ahead and iterate through all of the itinerary items, and then right here we'll just emit out the turn-by-turn directions that you saw here. Next one I want to show you is our major route, and this will integrate actually our search service. So instead of starting with an address here, I'm starting with a business name. So there's an extra step involved in here to go and get the information we need to go and calculate the route for this. So click on the button, and this will take just a second. So what this is going to do is it's going to go and get all of the major routes right here. So there's 4 major highways within that lead into the Los Angeles Convention Center. And then I'm going to take that information as well, and then I'm going to go and get a static map that's going to draw all the major routes into the Los Angeles Convention Center. So let me show you how you do it. Okay. So first thing is create a new search request object. We'll set its token. We'll set the query property. So this is a single box query, one box query. We're not going to do a structured search here. Create a new search service client, and then simply call the search method on our client. Now with the results we get here from the search response, I don't want to go into too much detail here just because I want to kind of keep moving on time. But what you're doing is you're going to cast the search result into a business search result object here class, okay? And then iterate through the locations, and then what we're going to do is we're just simply going to pull the first location that comes out of this, and it's, because this is a demo, it's the right location, so we have nothing to worry about. Okay, so now we've got our location, and we're going to use that later, because now what we're going to do is we're going to create a new static map, and we're going to point to it the latitude and longitude so that it knows how to create a new route to that. So what we'll do is we'll new up a new map URI request object, set its token again, and then we'll set some options in here. So again, we need to set the image size for the control that we're going to host that, that static map into. We'll set our map style. And then once we've set all our options, we'll put that back on top of our map URI request object. And now what's new here is setting this property, major routes destination. And this will take a new location object, and then we'll pass in our latitude and our longitude in here. So this tells it, when it goes and generates that static image, this is a location that I'm wanting to create major routes for. And then it will go and generate it for us. Okay, so we've got all of our properties set. We'll create a new search client, or imagery service client, and then we'll call the same function we did before, the get map URI, and then pass in the new URI request object. And then it's all the same with respect to the image. We'll just go ahead and we'll set the image URL to the map URI property here, and then we'll make it visible. Okay, the last piece. So then the major routes request. So this is the part that's generating the text right here. And this is actually even easier than doing regular routes, because you don't have to add really any waypoints. You just have one waypoint, and that's your destination. So we'll create a new major routes request object, and then we'll just simply set the destination. And within the destination, we're just going to set the description that we pulled out of the text box to the Los Angeles Convention Center, and then create a new location object and pass in the latitude and longitude. So just like creating other routes, we'll set some options here. So we say we want driving, and we're going to minimize for time. Create a new route service client, so the same service client as before. And then this time, instead of just calculate route, we're going to calculate routes for major roads. And that's it. Get a response object, then we'll loop all through all the results in there, because you're going to have more than one route this time. So you're going to loop through all the routes, and then within each of the routes, you're going to route through each of the legs. And that returns it here. So here's your route, loop through each route, and then here's each of your legs, and then, of course, these are each of your itinerary items. Oops. Okay. Good. Finally through all the feature stuff. Now I want to get to show you some cool stuff here. I know I went fast, and I promise all this content is available. You can go and just take your own sweet time and just enjoy it, wallow. It's good stuff. All right. Let me get back to my laptop here. I could have done 2 sessions on all this. All right. Time for some really cool stuff. So what we did is we created a little line of business demo. Me being kind of an enterprise dev, I'm kind of a platform guy, right? Map is cool, but I got other stuff I got to do, man. I got a business I'm trying to run. I've got people I'm trying to support. I'm trying to help these guys make money so I can keep a job. So how do I integrate maps into stuff I may be doing every day? So we came up with this notion of this fictitious coffee company called Fourth Coffee, and they own a few coffee shops down here in Southern California. So what we've got is just kind of a default map. This is just your regular VE map here. And then we have some push pins around each of the stores. Now, Fourth Coffee Company doesn't really have a whole lot of respect for customers' privacy, so they also happen to know where all their customers are as well. And you can see we're using our push pin clustering in here, so we've got multiple customers here and then individual customers here. Now, here's where things start getting interesting. So we've plotted, we know the location of our customers, so we can geocode them And using the SQL spatial, the geography data types, we can store that location in SQL Server. When I hover over this person, this is just creating a new standard push pin. I can actually also run a query that says how much money has this customer spent within the last 12 months. Maybe we can, and since you know where they are, you can maybe send them a Christmas gift or something. The other thing you can do, besides invade people's privacy, is you can actually get some really interesting business intelligence on your stores. So these aren't just regular push pins, but what we did here is we said, well, how much is the total sales of this store? We can include that in part of the push pin information. Or maybe what is our monthly sales? So we created a little quick and dirty little HTML bar graph there. And then other interesting things you can do is you could run spatial queries. So tell me, from this store, how many customers do I have, say, in 1 mile? Or how many customers do I have in 3 miles or 5 miles? Right? So you can actually start to think that if I integrate the existing data that I know and then visualize it using a map, you can actually start to get some really interesting ideas. Now, for me, this took a while when I joined this team to kind of wrap my mind around this. But as I started going and thinking through all the applications I'd ever written, I thought, you know, I think having some kind of location-based thing around that might be a very interesting scenario and would provide a richer context and richer business intelligence for myself and the people I worked for. So let's kind of dig in here into how we built this thing. So we'll just kind of give you a little high level. So really, where it all starts, we've just got a very simple ASPX page right here. And we've got, again, our reference to our map control. And then we've got 2 JavaScript files here. And I'll go into each one of these. Secondly, we just created some data classes. So just wrapping up data. So I've got a customer class here that wraps or encapsulates a data row. And then I've got individual properties around each of them. And if you'll notice here, I have a very special data type, SQL geography, which is the location for our customer. And that'll come in handy a little bit later. I've then got a customers class, which wraps up multiple data customers, or multiple customers in here. You can just see filling this thing in as just a select star from customers right here. Same with stores. So I've got an individual store and then multiple stores. Then the other thing here, so since this is client side, a lot of script on this thing. I have a little HTTP handler that handles requests that come from the client, and then in the process request here, and then goes and then directs the action on what to do on that. And I'll go into this because I'll kind of what we'll do is we'll just kind of follow the data through here. So let's start right here. So here's our default JavaScript file, and here's a very familiar looking function, load map again. So we'll new up a map object, call the load map on it, just set some latitude and longitude, some styles there. Attach a couple of mouse events. And then 2 functions here. I've got show control panel. This essentially just creates this little floating div I've got right here. That's really hard to see. It doesn't matter. This shows the customer's stores. And then the other one here loads up stores. So what we'll do first is we'll go into here. And if this is undefined, which means we have no data in here whatsoever, first time run, it's going to call a function here called load.json. Now load.json actually, in the function here, and I'll just kind of briefly show it to you, creates an XML HTTP object. And where are you? There you go. It actually, load.json then immediately calls a function called getData, pass in the data, so we want all stores. So it's going to create an XML HTTP request and then call our handler forthCoffee right here. So let me go back up to the top. Sorry if I'm giving you vertigo by scrolling this fast. Okay, so we're going to call our stores. So here in our handler, process request is going to fire, and then it's just going to start going through, and it'll say, whoop, all stores. Great. That's what we're going to do. Let's create a new stores class here. So we'll follow this in. Great. So select star from all stores. Looks good. The next thing it'll do is it wants to do a response write. So what it's going to do is we created a little function called getJSON. And this is the data we're going to format and send back down to the client in the response object. So Let me show you that. So what we'll do is we'll just start with a simple string builder object here, and then we'll iterate through every store that we've got in our stores class here. So just using the string builder, we'll go and pull the store ID. And then for location, location is actually a binary type. It's not a latitude and longitude. Virtual Earth doesn't understand SQL geography natively. So what do we have to do is we've got to go in here and pull out the latitude and longitude for each one of them. And this is just simply, right, SQL geography. Whoop, give me a little, there we are, SQL geography, the data type. So we'll pull the latitude and the longitude out, and then we'll get a bunch of other data. So we'll get the address, the city, the state, the zip, and then we're going to pull out these spatial query results, so customers within 1 mile and 3 miles and 5 miles. How am I doing on time? This thing ends at 3. Oh, I'm actually doing pretty good. Okay. Okay. So I just jumped over to this function here, excuse me, the property. So here for this property, we want customers within 1 mile, right? And this is in the context of going and grabbing this data. What it does is that it calls the customers class and then calls an override in here. And what it's going to do is that it's going to pass in an instance of the store and then the length, right? So for customers within 1 mile, it looks like this. And then for 3 miles, and then for 5 miles. So let's look at this then. Okay, so here's the overload here where we're taking a store and then an integer for the number of miles. Now, SQL Spatial doesn't understand miles natively, but it does understand meters. So the first thing we're going to do is just convert all the miles to meters so that they can go and use it within the application or within the database here. The second thing we'll do is we're going to create or call a separate or a very special kind of SQL statement here. So this first part looks very normal, at least for a SQL person like me it does. Select star from customers where. The second part is where we get the SQL Spatial functionality out of, and really where this stuff is so powerful. So what this function is doing here is it's saying, show me all the customers compare the customer location within 1 mile or that number of meters from the center point of the store location here, right? And return me just those customers that are just within that distance. So we create a new location parameter here, and then here's the store location, right? That gets passed to here. Okay, so this is going to get rolled up. We're going to get our JSON data back. That's going to go back all the way to our JavaScript file. And now what we're going to do is we're going to create a new shape layer. So again, as before, just as I showed in the clustering demo, we'll create a new VE custom icon specification. In fact, this is for any shape layer if you want to create a custom icon. We'll call that coffee shop. Next, we're going to iterate through all of the coffee stores that we return back. So the first thing we'll do is let's create a new virtual earth lat long, and here we have our latitude and our longitude that we busted out of the location data type. And then we'll create a new VE shape, and we'll type pushpin, and then set its location object right here. And then next we'll just start setting the rest of the data in here. So the title, here's our HTML graph right here, and then description, address, city, state, zip, all the sales, and then of course all the customers within 1 mile, 3 miles, and 5 miles. And then we'll simply just add the shape, and then add the shape layer to the map. And that's it. So not too hard. I mean, some of it's a little new. The spatial queries are new. But generally, and then of course interacting and putting this stuff on Virtual Earth may be new. Well, not for most of you, since most of you have done this, worked with Virtual Earth before. But really, you can, with the little extra code, you can really do some powerful stuff. So I will show you one more thing, and then we're going to go to Q&A. So the other nice thing about having things on a map is being able to do kind of ad hoc queries, right? Everybody that does SQL likes doing ad hoc queries. In spatial, you can do them as well. So in using our little draw polygon JavaScript file, I'm able to draw a little polygon here right on the map. And let's just say this coffee shop right here down in Norwalk, not performing too well. I don't know, maybe I want to shut this thing down. So let's see, what have we got here for customers? So within this area here, I've got 13 customers, and those cheapskates have only spent $13,000 with me in the last 12 months. So maybe I want to drop this store, do something else, or move it. So how do we do this? What we'll do is our draw polygon here. Now, there's a lot of code in here, and like I said, I'm giving this all to you, so don't sweat it. Don't be writing this stuff down. So what we have here is just an on-mouse click function. So you noticed earlier we're capturing or trapping for the mouse clicks. And what we're doing is in here, I am basically just holding a shift key down and then just clicking the left mouse button. Right? So here you can see I'm going to call a function here called pixel to lat long. So I'm going to get the latitude and longitude for that pixel I clicked on. Here's a little bit of state control in here that's controlling the drawing. So if I'm not drawing and holding the shift key and the left button, start the drawing or add points to the drawing. The one I'll go into here is complete polygon. So once we get to complete polygon here, we'll have built a lat long string right here, and then we're going to make our call back up to our HTTP handler, and we're going to call get customer data in polygon. So we're back in our handler right here, and here's customer data in polygon, and then it's going to request the query string. So here's all the poly points that we've then passed in. So the first thing we'll do here is we're going to split them by the semicolon. So we'll go ahead and call the split function, because these are all coded using a semicolon in here. Next, we want to go and create the SQL geography type. So we've got to get it into a SQL geography type from the virtual Earth version, if you will, with the array string. So what we'll do is we'll pass that into this function here. So in fact, let's do this. I'm going to let's just go run this in the debugger. That'll prove to you that this works. Great. Okay. So what I'm doing here is I'm going to create a new SQL geography type from the poly points that I've just passed in. So here's an array of points. You can see right here. So now what I'm going to do is I'm going to for each through them here. Check if it's null, and if it is, I'm going to start it. So we've got a little bit of state going on in here. So what we'll do is we'll create a new SQL geography builder right here, and then call begin geography. Okay? And then we're going to take our points. So we've got our two right here, our latitude and longitude, call convert to double, and then add them in. And then just loop through each of them here. Okay, all the way through. So what we'll do is then on the SQL geography builder, we're called end figure, end geography. And then something that I suggest you all do is after you start, if you're using this to build a geography, is you cast it into a SQL geography type using the SQL geography builder constructor geography and see if it works. It didn't work. Fail. Does not represent a valid geography. So, what did I do wrong here? I can tell you. SQL Spatial, because it's supporting the OGC standard, has a very specific way in terms of what the polygon should look like. When I went and created it, I went clockwise. It doesn't like that. You've got to flip the thing. So you throw that in a try block. And so what do? We're going to reverse them. And guess what? That works. So we've got our array here. We've got our 10 customers. I kind of blew past the rest of this because we have to get to questions. But I hope that was able to give you a little bit of an insight. I hope you all went to Isaac Kunin's session on SQL Spatial, and if you did not, go watch it online because he actually works for the product team. I'm just a faker when it comes to SQL Spatial. I just think it's cool stuff. But when you add that stuff in with Visual Studio, or excuse me, with Virtual Earth here, and in Visual Studio, you can make some pretty compelling applications, and I hope you'll all give it a try. So, quickly, SDKs, examples, blogs, everything a growing, budding Virtual Earth or seasoned vet needs, dev.live.com/Virtual Earth. Please go there and check it out. I keep that thing up to date with fresh content as often as humanly possible. Sometimes every week we've got new stuff up on there now. The samples from this session, plus bonus content, Chris Pendleton's blog, blogs.msdn.com/Virtual Earth. Chris is a prolific poster, so lots of great content on there from him. I would recommend just going and scraping his blog for all the great samples he's got up there. If you have questions on licensing, which nearly everybody does, email maplic@microsoft.com. If you are a partner or want to become a partner or interested in being a reseller for Virtual Earth, email us at mapptner@microsoft.com, and we'll help you out there. Please fill out your eval. I've got some side bets going on here, and so please fill those out. The sessions will be available at Microsoft PDC. Give it, I think, roughly 24 hours, and we'll get that up there. And right now, I want to introduce Harish and Keith and Eugene from our product team, and then we'll do Q&A. So for the questions and answers, please use the microphone so we can capture the recording. Check, check.
Hi. Could you talk a little bit about the confidence levels and the geocoding and what levels they are and how they correlate to understanding, to what granularity it was able to geocode the addresses that are passed in?
Okay, so basically we have 3 levels of confidence, which are high, medium, and low. Basically, think of high as it's very good. You can operate on it. Feel free. Think of it as an exact match, roughly. Medium is we have good confidence in it, but it may not exactly match what you've got. Additionally, we also have what we call an entity type on each one of the geocoding results back. So you can actually look at each one of those types and see whether or not it matched an address, it matched a roadblock, the postal code, for example. So that way you can actually see what type it exactly matched.
I have a couple quick questions, and I don't know if you can answer much on licensing here, but in general, when can I use Virtual Earth to make mashups for free, and when do I need to think about buying licensing for it?
So generally the rule of thumb is if you're building a commercial application, you should go and talk to us about getting a production license from us. If you're building a community site or a mashup of some sort, you're generally fine. Out on dev.live.com, we've actually got a terms of use out there. Go and click it. It's a bit of legalese, but generally speaking, there are some upper limits in terms of how many transactions, so how many geocodes or tiles you could pull down. But in nearly all cases, most of the types of sites like that, like you're describing there, are perfectly fine.
What about for government sites, like local government?
Yeah, state and local government and federal have to go and do a commercial license with us.
Okay. And then the second, if I'm placing points on the map, does that all happen on the client if I'm doing it, like using JavaScript, or do those points get sent up at all across the wire?
Yeah, spread it around.
If you're using the JavaScript client, those points are all on the client. They don't go up through the server. But it depends how you're importing your points. If you're reading your own data, you have your own customer data, and then you can use the shape class to add the push pins to the map on the client side. But we do have other types of import. So if you have like a KML file or GRSS, we do support cross-domain import where you can the data does get uploaded to our servers, but we don't track it. We just parse it and then send it back to the client. So that's one way that does pass through our servers. Or if you're importing a VE collection from our servers, which is an MSN storage, if you create a collection through the client side. But primarily, it's all on the client if you're creating your own push pins.
So like the coffee shop example, if those sales figures are sensitive data, they're not going to get sent across the unsecure connection?
Correct. The sensitive data will stay with your application and does not go through Microsoft.
Okay, thank you.
I've got two questions as well. The first is, do you guys know if the spatial stuff in SQL is in SQL Express, or do you have to buy the enterprise or higher version? And then the other question is, are you guys planning a native WPF or Silverlight control for Virtual Earth?
So I'll answer the first one. Actually, I probably can answer them both. Yes, spatial is in SQL Express. Knock yourself out. The second question around whether or not we're building a Silverlight control, we can't really comment. We announced, we unveiled kind of a very early prototype of one at Mix last year. But we've got really nothing further to announce right now.
Thanks.
Sorry.
So in your coffee shop example, if an employee wanted to visit 10 customers to bring out deliveries, would there be any support for calculating the most optimal way to visit all 10 customers, the traveler and salesman?
Yeah.
No, currently we don't have that, so but we can provide you the sample code, or like we can help you out how to build that, but we don't have it on our servers right now. So
Okay, thanks.
you can contact us offline. So.
Sure.
Okay, so two questions as well. The first is you demonstrated the major routes on static maps. I'm assuming it's available for dynamic maps as well, but I wanted to ask.
So currently we don't actually expose that call in the JavaScript API in the Ajax map control. Okay. However, you theoretically could, build it into your application if you wanted to make the call to the web service from your application. Then you could render the routes on your map. But we don't provide a JavaScript API for that right now.
Okay.
So.
And then the other question is, you said that there were some upper limits on the geocoding requests. Is there any throttling on number of geocode requests per minute or anything like that?
There's no throttling on a per customer account ID basis, but there's throttling on the overall request per second to our data center. So we don't limit per account ID or per IP or something like that. So.
Okay, thank you.
If you wanted to go beyond the zoom level of your tiles, is there any server pass-through that I can supply partial tile or extend the plus button, or do I have to do a JavaScript client-side job?
So we have a tool that came out of Microsoft Research called MapCruncher, where you can generate your own custom imagery tiles to plug into Virtual Earth, and we support tile layers where you can plug your own imagery in the map. When you add a tile layer to the map, you can actually specify a zoom level that's greater than the zoom level supported in Virtual Earth, so it can go down. And we actually have, if you go to the MapCruncher gallery, you can see some samples that zoom in pretty far in some areas. However, we don't. I believe the navigation control by default, we'll read the maximum zoom level and adjust based on that. But you can also always hide the navigation control and build your own custom navigation also, if you would like. But the primary thing you're looking for is probably MapCruncher, where you can actually specify a greater zoom level with your imagery. So.
Can you repeat the feature name and the source of where I get my hands?
Oh, MapCruncher. That's I don't know the exact URL.
You can stop by and we can give you.
Yeah, we can. If you come on up, I'll give you a business card and we can talk about it.
Great. Did everybody get a Virtual Earth T-shirt when they were here? No? Okay. We got a whole bunch of Virtual Earth T-shirts in the back of the room. Feel free to take one.
Just real quick, I was wondering how much longer you're going to support MapPoint web service?
There's no plan to terminate it in any near future, so not in the immediate time frame. So.
Great. Thank you, everybody. Safe travels.